Welcome to Career Guidance Max playlist. In this video, I'm going to start Unit 3 Functions of Several Variables. Is nothing but partial differential equation. Okay. So before going to start the sections, just you can understand what is partial differential equation. That means PDE, partial differential equation. Already you know that how to differentiate the term. Normal differentiation, you know that this is a partial differential equation. So first you can understand what is normal differentiation. So you will have the equation x square plus y square equal to 1. Differentiate with respect to x. Differentiate with respect to x means we can write 2x x square differentiation 2x and y square differentiation 2y into dy by dx we have to write. Here we differentiated with respect to x, right? Is equal to constant term differentiation 0. This is one model in differentiation, right? Next one, you will have xy is equal to 1. Differentiate with respect to x. That means both we need to differentiate. Here we have to apply product rule. So for x is considered u, y is considered v. Here you can apply product rule. Differentiation of uv equal to u into v1 plus v into u1. That means v dash u dash, differentiation term. Here I am going to differentiate keeping x as a constant and differentiate y dy by dx. Okay, and plus keeping y as a constant and differentiate x with respect to x differentiation is 1 is equal to constant term 0. So you will get the value dy by dx. This plus y shift to right hand side, you will get minus y. This product x you can shift to right hand side, it gives in denominator term minus y by x. This is your differentiation term. But in partial, not like that. Partial, first we can fix the one function z equal to function of x comma y. Z equal to function of x comma y. Here this x and y are independent variable. Z is a dependent variable. This z is depend on this xy. The partial differential equation definition is in that it deals one dependent variable, at least minimum two independent variable. Otherwise we cannot apply the partial differential equation. Minimum you should know, you should have two independent variable. Here we taken two independent variable x and y. So let's see how to apply partial differential terms. So consider one function f. Okay, f is equal to, you will have some that is understood. F means a function of x comma y. Here you will have the equation x cube plus y cube plus x square y square. Okay, this is our equation. This equation I'm going to solve based on partial differential equation. Okay, I'm going to differentiate partially with respect to x first. Partially differentiate with respect to x. So f differentiation, the partial term you have to write dou f divided by dou x, right? Dou f divided by dou x, or this term you can write fx, both are same. Okay, this is called first derivative. Differentiate partially with respect to x means x differentiation what pa? 3x square, and plus here y cube differentiation with respect to x partially. Here there is no x term, so it is 0. There is no x term, it is a constant 0. And plus here x square into y square, partially differentiate with respect to x keeping y square as a constant, and differentiate 2x x square, you will get 2x. Okay, so this is your partial differential basic rule, how to differentiate partially. Very simple one. And the same equation I am going to partially differentiate with respect to y. Okay, so dou f divided by dou y is equal to, I'll write this term fy, both are same only. Now I'm going to partially differentiate with respect to y. So x cube, there is no y term, so it is 0, and plus y cube differentiation 3y square, and here plus x square and y square both you will have. Here I'm keeping this x as a constant, x square as a constant, y square differentiation is 2y. Okay, so this is the basic partial differential equation. Okay, so when I am applying partial differential equation, suppose I am partially differentiating with respect to x means keeping y as a constant. Okay, or suppose I am partially differentiating with respect to y means keeping x as a constant. Okay, so this procedure we have to apply in functions of several variable. In this unit I am not going to teach completely, so important topics only I will teach. Okay, the first one I will take Taylor series. From this section you will get 1 8 mark from your university, the important one. Okay, the very simple one also. Here the formula is function of x comma y equal to f of a comma b. This f of a comma b means in your problem you will have one function. In that function directly we have to substitute the point a b. You will get f of a comma b plus 1 by 1 factorial of x minus a into f of x. This f of x is represent first derivative with respect to x. Here you should understood f of x at point a comma b. Here I didn't mention that a comma b. You should understand always. Here you have a comma b plus y minus b into f of y. X minus a is represent x, y minus b is represent y, f of y. This is first derivative, and plus 1 divided by 2 factorial x minus a whole square, x square. So I'll write f double x, second derivative, plus 2 into x minus a into y minus b. So I'll write f of f x and y, fxy, x minus a, y minus b na fxy, and plus y minus b whole square, y square. That means I'll write f double y, second derivative. Okay, here you can remember one formula, a plus b whole square, a square plus 2ab plus b square. Like that you can understand here. Okay, very simple one. And 1 divided by 3 factorial x minus a whole cube means you should understand f triple x, x term triple time. Okay, plus 3 into x minus a square into y minus b. That means f double x into y, that derivative, plus 3 into x minus a y minus b whole square. That means fx double y plus y minus b whole cube means f triple y term cube na thrice we have to differentiate partially that function. So this is the general formula. This third derivative you can relate it with the a plus b whole cube formula. Okay, the very simple one. Here we may substitute x minus a equal to h and y minus b equal to k also, but you can don't substitute these points. So why? Because while doing problem they may give expand the Taylor series for the function in terms of powers of x and y. In terms of powers of x and y means in your problem there is no a value, there is no b value. That means you should consider that a b equal to 0. Sometimes they will give expand the function in the term of at a point 1 comma 0 or 0 comma 1, any point. That means you can consider that points are a b. Here you have to substitute a equal to b equal to, like that. Okay, the very simple one. So we can follow this formula, very simple. Based on this we will solve some problems. Okay, so problem number 1, based on the Taylor series formula I am going to solve this problem. Expand e power x cos y about the point 0 comma pi by 2 up to third term using Taylor series. Here they given directly a comma b value. In the Taylor series you will have the formula x minus a, y minus b. Already I told in powers of x minus a, y minus b means you should understand this concept. Suppose in your problem they given x minus 1 and y plus 1 means your a value here 1, here your b value minus 1, because your formula x minus a, y minus b. If they given x minus 1, y plus 1, you have to take a equal to 1, b equal to minus 1, like that. Or in powers of x and y, in your question they given only x and y means here there is no a value and b value. You can take a equal to 0 and b equal to 0. That is the procedure. Here in this problem, they given directly the point a equal to 0 and b equal to pi by 2. This e power x cos y I am going to write. First, you can write the function at values they given directly 0 comma pi by 2. Okay, so I'll write the function of x comma y is equal to, I'll write e power x cos y. Okay, so in that function you can substitute the point 0 and pi by 2. Consider first one x, second one y. So f is equal to e power x equal to 0 cos y equal to pi by 2. Cos 90 is 0, so your function value is 0. In your formula, the first step, our function of a comma b we identified, that is 0. Then first derivative we have to identify fx fy. So first fx means this function I'm going to partially differentiate with respect to x. That means here cos y is constant, e power x differentiation e power x itself. And next I'm going to find fy. Fy is function partially differentiated with respect to y. That means here e power x constant, cos y differentiation is minus sin y. Here you can substitute the point fx at a point 0 comma pi by 2. So e power 0 cos pi by 2 equal to 0. Fy at a point 0 comma pi by 2 minus e power 0 sin pi by 2. Sin pi by 2 is 1, e power 0 is 1, you will get minus 1. First derivative over. And next f double x, fx term again I'm going to partially differentiate with respect to x. So cos y constant, e power x differentiation is e power x, and fx I'm going to partially differentiate with respect to y. So e power x constant, cos y differentiation minus sin y. Okay, and fy again I'm going to partially differentiate with respect to y. E power x constant and minus sin y differentiation cos y. Okay, here I am going to substitute the point f double x equal to e power x equal to 0 cos y equal to pi by 2. I will get 0 because cos 90 is 0, and fxy equal to minus e power 0 sin pi by 2. Sin pi by 2 is 1, e power 0 is 1, you will get minus 1. And the next one, f double y is equal to minus e power x equal to 0 cos pi by 2. Cos pi by 2 is 0, so entire term 0. Okay, and next third derivative f triple x, fx term again, f double x term again partially differentiate with respect to x. Cos y is constant, e power x differentiation e power x. Next f double x y, that means f double x term partially differentiate with respect to y. So e power x constant and cos y differentiation minus sin y. Then you can find f x double y. So fxy term again partially differentiate with respect to y. So I will get minus e power x constant and sin y differentiation cos y. F triple y. Fw already we know second derivative. This term again I'm going to partially differentiate with respect to y. So minus e power x constant, cos y differentiation minus sin y. So minus into minus plus, here you will have sin y. Okay, and substitute the point f triple x e power x equal to 0 cos y equal to pi by 2 equal to 0 because cos 90 is 0. f double x into y equal to minus e power 0 sin pi by 2 equal to sin pi by 2 is 1, e power 0 1, you will get minus 1. And fx double y is equal to minus e power x equal to 0 cos pi by 2. Cos pi by 2 is 0, e power 0 is 1, I will get 0. F triple y is equal to e power x 0 sin y equal to pi by 2. I will get 1. So these all values we have to substitute in our Taylor series formula. After finding this, we have to write the Taylor series formula. So this formula again we have to write. So this is the general procedure. So this is our Taylor series formula, already you know that. So in this Taylor series formula, I am going to substitute first initially that a b value. Here the point a equal to 0 and b equal to pi by 2. The question itself they given this point. Okay, substitute in the formula. Function of x comma y is equal to function of a equal to 0, b equal to pi by 2. Okay, and plus 1 by 1 factorial we can write 1, and x minus a, x minus 0 fx plus y minus b equal to pi by 2 and fy, which is first derivative, and plus 1 divided by 2 factorial. 2 factorial is 2, and substitute the point x minus 0 whole square f double x plus 2 into x minus a equal to 0 and y minus b equal to pi by 2 fxy plus y minus b equal to pi by 2 whole square f double y. Okay, and plus third derivative 1 by 3, not 1 by 3, 1 by 3 factorial is 6, you will get 1 by 6 x minus a equal to 0 whole cube f triple x third derivative plus 3 into x minus 0 whole square y minus b equal to pi by 2 f double x into y plus 3 into x minus a equal to 0 y minus b equal to pi by 2 whole square and f x into double y plus last term y minus b pi by 2 whole cube f triple y. Okay, so this is our formula. We have to find up to third degree. Okay, third derivative. So now I'm going to substitute here all the points f of f, fx, fy, like that. Okay, the first one f of 0 comma pi by 2. So f of 0 comma pi by 2 is nothing but your f value. You should understand here f of 0 comma pi by 2 meaning here. You should understood. So f of 0 comma pi by 2 is 0 and plus x into f of x equal to 0 and plus y minus pi by 2 fy is minus 1, first derivative over, and plus, so next 1 by 2 f double x is 0, so straight away we can write x minus 0 square into f double x. Here x square into f double x is 0 plus 2 into x minus 0, I'll write x, and this y minus pi by 2 fxy value is minus 1 and plus y minus pi by 2 whole square f double y is 0. Okay, and plus 1 by 6, the first term x cube f triple x is 0 plus 3 into x square y minus pi by 2 and f double x y is minus 1 and plus 3 into x minus 0 x y minus pi by 2 whole square. This fx double y is 0 and plus y minus pi by 2 whole cube. This f triple y is plus 1. We substituted all the values. Now we have to simplify these terms. So equal to minus of y minus pi by 2. Right? First term 0. And here this one 0 plus 1 by 2 of minus 2x y minus pi by 2. Remaining these two terms are 0 plus next 1 by 6 of first one 0, third one 0. So minus 1 into 3x square minus 3x square y minus 5 by 2 and plus y minus pi by 2 whole cube. Okay. So now we can write minus y plus pi by 2. I multiply with the minus. Okay. And here 2 cancel, minus of x into y minus pi by 2. And here 3 divided by 6, 1 divided by 2. Minus 1 divided by 2 x square y minus pi by 2 and plus 1 by 6 y minus pi by 2 whole cube. Okay, so this is our final answer. Here I'll write f of x comma y. Okay, so after finding these table values, you can write the Taylor series formula. Then you can substitute first the points a and b points. Then you can substitute one by one fx, fy, function value, all those things. Finally, you can simplify at most level. Okay. So this is our final answer for this sum. Maximum you can write 5 steps or 6 steps. That's enough. Okay. So in this video we completed Taylor series. Within that I completed only one problem. In next video we will continue Taylor series. Okay. Thank you, Pa.